Hello everybody, welcome into another lesson. So today we are going to solve polynomial equations by factoring. And in today's lesson, all of the polynomial equations will be able to be factored. And for the sake of today's lesson, we are only going to focus on the real solutions, on the real number solutions. There will be a time and a place we'll do the whole complex solutions, but that's not in today's lesson. Also, there are methods for dealing with polynomial equations that are unable to be factored. We'll visit that in another lesson, but today should be relatively easy. We're just going to basically put together all we've learned with how to factor polynomials, and then we're going to solve the equations. So here you have x to the third minus 3x squared equal to 0. Much like in a quadratic equation, you completely factor it, then you set each of the factors equal to 0. So, of course, you have a common x squared you can factor out. So let's do that. You would get x squared times the quantity of x minus 3. Well, now you just set each of your factors equal to 3. X squared equal to 0 would just simply give you x equals 0. And then you have x minus 3 equal to 0. That would actually give you x equals 3. So your solutions are x equals both 0 and 3. But notice something here. You have 0 actually occurs twice because the x is squared. That actually counts as two 0 values, but you only have to list it once in your solutions, but 0 actually is two of the zeros in this case because the x is squared. And then you have 3. So really there's 3 solutions, but you only have to list 2 of them since 0 occurs twice. Which, when we get to the graphing polynomial equations, we'll explain more about that. And I already did kind of allude to it when we were on the quadratics, but there's more to cover with the polynomials. Okay, similar one. So we have 2x to the third minus 6x squared is going to be equal to 0. So we have 2x to the third minus 6x squared is equal to 0. Well, there's a common 2x to the second, right? We can certainly factor that out. You have 2x to the second times the quantity of what would be x minus 3 equal to 0. Well, when you're solving, if you just have a constant that's multiplied by the factors, you can divide both sides by the constant, and then you would just get x squared times x minus 3 equals 0. And then you're going to end up having similar solutions. Since x is to the second power, you would literally get x equals 0, and you would actually have two 0 values for that. And then x minus 3 equals 0, giving you x equals 3. So your values for x would be 0 and 3. And graphically speaking, finding the values of x, where you're finding your zeros, those are the x-intercepts on the graph. Alright, now, what if we have something like 3x to the fourth plus 15x squared minus 72 equal to 0. So we have 3x to the fourth plus 15x squared minus 72 equal to 0. Well, you could definitely factor out a common 3, right? So that'd be 3 times the quantity of x to the fourth plus 5x squared minus 24 equal to 0. Well, you can divide both sides by 3 to get rid of that constant multiple of 3. You would now be reduced to x to the fourth plus 5x squared minus 24 equals 0. And then when we talked about in yesterday's lesson factoring even power polynomials, you could treat it like a quadratic. This is going to factor into the quantity of x squared plus 8 times the quantity of x squared minus 3 would be equal to 0. Well, the x squared minus 3 can factor further because that's a difference of squares, but your x squared plus 8 can't. That's a sum of squares, which would give you two imaginary results. Today we only care about the real numbers. So just take that x squared minus 3, set that equal to 0. Well, that's going to give you x squared equals 3, which would have to mean that x equals both plus and minus the square root of 3. So those are your two real solutions, are x equals plus and minus the square root of 3. And for today's lesson, we're not dealing with the imaginaries. Just focus on the reals today. All right. Now, we have x cubed plus 27 is equal to 0. So we have x cubed plus 27 is equal to 0. Well, remember this is a sum of cubes. So we'll factor the sum of cubes. You would end up getting x plus 3 times the quantity of x squared minus 3x plus 9 equal to 0. Well, here's the thing. That quadratic factor you get of a sum of cubes, it'll always be imaginary. You'll always have two imaginary numbers that don't factor. When you stick it in the quadratic formula, you will always, 100% of the time, get imaginary numbers. So all we really need to focus on here is this x plus 3 equal to 0, since we're only worried about the real solutions today, which would just give you that x equals negative 3 as your only real solution. There are two more solutions in the complex number system, but again, we only care about the real solutions today. All right. We have x to the third plus 2x to the second minus x is equal to 2. So x to the third plus 2x to the second minus x equals 2. Much like with a quadratic equation, especially a type where you can clearly see you're going to be able to factor it, you want to make the right-hand side equal to 0. So we need to subtract 2 from both sides. So if you do that, you'll get x to the third plus 2x to the second minus x minus 2 would equal 0. And if we look at this definitely looks like a factoring by grouping, right? So take your first two terms, you have a common x squared you can factor out. That would give you x squared times the quantity of x plus 2. Now, look at your negative x and negative 2. Can't you factor out a negative 1? So that would be negative of the quantity of x plus 2. All those equal to 0. So x squared times the quantity of x plus 2 minus the quantity of x plus 2 equals 0. Now, the x plus 2 is common to both terms, so we can factor that out. You'll get x plus 2 times the quantity of x squared minus 1 is equal to 0. Which now, x squared minus 1 is a difference of squares that will factor further, so you would end up getting the quantity of x plus 2 times the quantity of x plus 1 times the quantity of x minus 1 equal to 0. So now, take each of these factors, set them equal to 0, x plus 2 equals 0, that would give you x equals negative 2. Now we have x plus 1 equal to 0. That would give you x equals negative 1, and then take x minus 1, set that equal to 0. that would give you x equals 1. So your solutions to this would be x equals -2 and then plus and minus 1. So you have 3 real solutions for this. X equals -2 and then both plus and minus 1. All right. What's next? Let's see. X to the 4th plus 7x to the 3rd minus 8x minus 56 is equal to 0. So we have x to the 4th plus 7x to the 3rd minus 8x minus 56 equals 0. Now, this is an even-powered polynomial. However, it's not a conventional one. Notice you skipped the quadratic term entirely. This one will actually be solved by factoring by grouping. Look at your first two terms, x to the 4th and 7x to the 3rd. You can factor out a common x to the 3rd, so you'll get x to the 3rd times the quantity of x plus 7, right? Now, you would end up taking, you have the -8x and -56, you can factor out a common -8, so that'd be minus 8 times the quantity of x plus 7, all this equal to 0. Well, we can now factor out a common x plus 7 with both terms. This would give you x plus 7 times the quantity of x to the 3rd minus 8 equal to 0. Well, x to the 3rd minus 8 is the difference of cubes, right? We could definitely factor that out. This would give you x plus 7 times the quantity of x minus 2 times the quantity of x squared plus 2x plus 4 is equal to 0. Well, that quadratic factor, again, the quadratic factor from a difference of cubes never has a real result. It's only imaginary. And since we only care about the real results, let's set the two linear factors equal to 0. So take x plus 7, set that equal to 0. Well, you get x equals -7. Then take the x minus 2, set that equal to 0. You'd end up getting x equals 2. So you only have two real solutions of x equals -7 and positive 2. Those would be your two real solutions. And then, of course, we have two imaginary solutions, which we're not worried about today. All right. Let's see. 2x to the 4th minus 26x squared plus 72 is equal to 0. So we have 2x to the 4th minus 26x squared plus 72 is going to be equal to 0. Well, we could definitely factor out a common 2, right? So you'd have 2 times the quantity of x to the 4th minus 13x squared plus 36 would be equal to 0. Well, you could definitely divide both sides by 2. That would just leave you with x to the 4th minus 13x squared plus 36 equal to 0. Now we can treat this almost like a quadratic since we have an even power. This would factor into x squared minus 4 times the quantity of x squared minus 9 equal to 0. And if you FOILed all this out, you would get x to the 4th minus 13x squared plus 36. Now, both of these factors are the difference of two squares, so they can each be factored further into the quantity of x plus 2 times the quantity of x minus 2. And then that x squared minus 9 will factor into the quantity of x plus 3 times the quantity of x minus 3. All those would be equal to 0. Now just take each of your solutions, take each of your factors, set them equal to 0. So x plus 2 equals 0, x equals negative 2, x minus 2 equals 0, x would equal positive 2, x plus 3 equals 0, x would equal negative 3, and then x minus 3 is equal to 0, which means x would equal positive 3. So you have 4 real solutions. X is going to equal, that marker took a crap on me already. So x is going to equal plus and minus 3, as well as plus and minus 2. So those are your 4 real solutions. X equals plus and minus 3 and plus and minus 2. All right. So let's see here. 3x to the 7th minus 243 x to the 3rd is equal to 0. So we got 3x to the 7th minus 243 x to the 3rd is equal to 0. You can factor out a common 3x to the 3rd between both terms. So let's factor that out. You would get 3x to the 3rd times the quantity, then that would be x to the 4th minus 81 equal to 0. Well, you can definitely divide both sides by 3, which would just now leave you with x to the 3rd times x to the 4th minus 81 would be equal to 0. Well, x to the 4th minus 81, you can almost treat that like a difference of squares. So that'll factor into x to the 3rd times x squared plus 9 times x squared minus 9 is equal to 0. While your x squared plus 9 won't factor into anything real, you'll have 2 imaginary answers, so forget that. But the x squared minus 9, that's a difference of squares, so this will factor into x to the 3rd times x squared plus 9 times x plus 3 times x minus 3. I need to get new markers all together. So if I take each of the real factors, set them equal to 0, that x to the 3rd equal to 0 would just give me x equals 0, right? X plus 3 equals 0 would give me x equals negative 3. And then the x minus 3 equal to 0 would give me x equals 3. So x would have 3 real values of plus and minus 3 and then 0. Those would be your 3 real values. And actually, that x equals 0, that counts as 3 of your zeros. So you'd have 3 plus 2 is 5, then you'd have 2 imaginary. So x is actually 3 of your zeros since it occurs 3 times, since it's to the 3rd power. In a few lessons, we're going to cover something called the fundamental theorem of algebra, which basically states the degree of your polynomial is how many zeros you're going to have in the complex number system. All right, let's see. X to the 3rd plus 3x squared minus 2x minus 6 equals 0. So we got x to the 3rd plus 3x squared minus 2x minus 6 equals 0. Definitely looks like a factoring by grouping, right? So look at your first 2 terms. You could factor out an x squared. That would end up giving you x squared times the quantity of x plus 3. Man, I'm having a rough time with these markers. All right. There we go. X plus 3. And then with a negative 2x and negative 6, you could factor out a negative 2. So you'd have minus 2 times the quantity of x plus 3 equal to 0. Well, you could factor out a common x plus 3 between both terms. So you would get x plus 3 times the quantity of x squared minus 2 equal to 0. Well, we can actually factor x squared minus 2 since it's the difference of squares. Or you can just solve for it. So x plus 3 equals 0, you would get x equals negative 3, right? Now, x squared minus 2 equals 0 would give you x squared equals 2, which means x would equal plus and minus the square root of 2. So you have three real values. X would equal negative 3, and then plus and minus the square root of 2. Those would be your three real solutions to x. X equals negative 3, and then plus and minus the square root of 2. I may just write in black the rest of the way. All right, let's see. 8x to the third minus 1 equals 0. So we have 8x to the third minus 1 equals 0. Well, definitely a difference of cubes, right? So this will factor into 2x minus 1 for your linear factor times your quadratic factor, which would be 4x squared plus 2x plus 1. All that would be equal to 0. And of course your quadratic factor will have two imaginary solutions. It always does with the sum or difference of cubes. So since we're only focused on the real solutions, let's just look at that 2x minus 1. So 2x minus 1 equals 0 would give you 2x equals 1, giving you the only real value for this would be that x equals 1/2. So x equals 1/2 would end up being your only real solution to this polynomial equation. All right. X cubed plus 8x squared equals negative 16x. So we have x cubed plus 8x squared equals negative 16x. Well, we definitely want to make the right-hand side equal to 0, right? So add 16x to both sides. That'll produce x to the third plus 8x squared plus 16x is equal to 0. Well, now we notice between the three terms on the left, we can factor out a common x, right? So you'll end up getting x times the quantity of x squared plus 8x plus 16 equals 0. Well, let's look at the quadratic factor. Clearly that's a perfect square trinomial, right? So this will factor into x times the quantity of x plus 4 raised to the second power would equal 0. Well, let's see. Set each of these factors equal to 0. X itself equals 0, right? Now, that x plus 4, it's raised to the second power. So x would equal negative 4, but that negative 4 will actually count for two of your zeros since the factor using it is raised to the second power. So x would equal negative 4 and 0. And graphically, we're going to talk about what that means when you have powers of factors pretty soon. So technically you actually have 3 real zeros because that -4 occurs twice, but you only have to list it once. I have about 7 more. Okay, let's see. X to the third minus 5x to the second plus 5x minus 25 is equal to 0. So we got x to the third minus 5x squared plus 5x minus 25 equals 0. This is definitely going to be factoring by grouping. So factor out the x squared from the first 2 terms. You would get x squared times the quantity of x minus 5 plus your 5x and -25. You could factor out a common 5, so you get 5 times the quantity of x minus 5 would be equal to 0. Well, between both terms, you could factor out a common x minus 5. This would factor into x minus 5 times the quantity of x squared plus 5 would be equal to 0. Well, the x squared plus 5, the sum of squares, will produce 2 imaginary numbers. We only want the real numbers, so we just take x minus 5, set that equal to 0. That would just give you x equals 5. So the only real solution is that x equals 5. And then we have 2 more in the imaginaries, but x equals 5 is the only real solution. All right. Let's see here. 3x to the fourth plus 3x to the third is equal to 6x squared plus 6x. All right, so 3x to the fourth plus 3x to the third equals 6x squared plus 6x. Well, first we want the right-hand side to equal 0, don't we? So subtract 6x squared plus 6x from both sides. You would get 3x to the fourth plus 3x to the third minus 6x squared minus 6x, all that equal to 0. Now, look at all your terms. What do they have in common? They have a common 3x, right? You can factor out a common 3x, so that would give you 3x times the quantity of x to the third plus x to the second minus 2x minus 2, all that equal to 0. Well, you can divide both sides by 3 to just get x times x to the third plus x squared minus 2x minus 2 equal to 0. All right, now look inside your cubic factor. You can factor that by grouping, right? So let's make some brackets. You'll have x times the quantity of, look at your first 2 terms, you could factor out a common x squared. That'd be x squared times x plus 1. And then look at that -2x minus 2. You could factor out a common -2, so that'd be minus 2 times x plus 1. All that is equal to 0. So this will factor into x times the quantity of, inside your brackets you have a common x plus 1 on both terms, and then you have what's left over times the quantity of x squared minus 2. All those would equal 0. Well, in this case you have a difference of squares, so if you take the difference of squares, that would be x squared equals 2, which has to mean that x equals both plus and minus the square root of 2. And then of course you'll have x equals 0 and then x equals -1. So what you should get are 4 real solutions of x equals plus and minus the square root of 2, -1, and 0. Those would be your 4 real solutions for x. X equals plus and minus the square root of 2, -1, and 0. And I have about 5 more. All right, x to the 4th plus x to the 3rd equals, x to the 4th plus x to the 3rd minus x equals 1. So we have x to the 4th plus x to the 3rd minus x equals 1. Well, we want the right side to equal 0, right? So let's subtract 1 from both sides. You should get x to the 4th plus x to the 3rd minus x minus 1 would all equal 0. This is definitely going to be a factoring by grouping, right? So factor out the x to the 3rd from the first two terms. You would get x to the 3rd times the quantity of x plus 1. Now in your second two terms, at -x minus 1, you can factor out a -1. So this will be minus the quantity of x plus 1. All that equal to 0. Well, both terms have a common x plus 1, so you could factor that out. You would get x plus 1 times the quantity of x to the 3rd minus 1 equal to 0. Well, that x to the 3rd minus 1 is just the difference of cubes, right? So we can factor that. You would get the quantity of x plus 1 times the quantity of x minus 1 times the quantity of x squared plus x plus 1 equal to 0. Well, that quadratic factor, again, whenever you have a difference of cubes, you'll never get a real value when you use the quadratic formula. You'll only get imaginaries. So all we're concerned about are the real values. So that x plus 1 equals 0 will give you x equals -1. That x minus 1 equals 0 will give you x equals +1. So x has two real values of both plus and minus 1. Those are the only two real values, x equals plus and minus 1. All right, I have 4 more. All right, so 4x to the 4th plus 20x squared equals -25. So we have 4x to the 4th plus 20x squared equals -25. Of course, we want the right-hand side to equal 0, so add 25 to both sides. You end up getting 4x to the 4th plus 20x to the 2nd plus 25 would equal 0. And you can treat this as almost quadratic. If we look at this, this actually looks almost like a perfect square trinomial, right? This would factor into the quantity of 2x squared plus 5, that quantity squared. And if you expanded it out, you would end up getting this exact thing here. Well, 2x squared plus 5 itself would give you imaginary solutions, right? In this case, there's no real solution. We have actually no real solution to this. We would have 4 imaginary solutions, but we would have no real solution. And it's important to say, don't ever say no solution, say no real solution whenever you're solving polynomial and quadratic equations, because you have to leave open the possibility of imaginary solutions in the complex system. That's why you say no real solution as opposed to just no solution. Because to say there's no solution entirely is untrue. Alright, 3 more. Negative 2x to the 6th equals 16. Negative 2x to the 6th equals negative 16. Well, let's go ahead here and let's make the right side equal to 0. So you would get negative 2x to the 6th minus 16 equals 0. Well, you could factor out a negative 2, right? You would end up getting negative 2 times x to the 6th plus 8 is equal to 0. Well, now what you're going to have here, just divide both sides by negative 2. You get x to the 6th plus 8 equals 0. This case actually looks a lot like a sum of cubes, right? It looks a lot like a sum of cubes. So this would break down into x to the 2nd plus 2. So x to the 2nd plus 2 times the quantity of x to the 4th minus 2x squared plus 4. Well, the pseudo-quadratic factor, which is the x to the 4th one, that'll never factor. It won't factor at all. So we don't worry about that. And the x squared plus 2, that would actually give you imaginary solutions. So once again, we also have no real solution to this one. So no real solution to this particular equation. I got 2 more. Three x to the 7th equals 81x to the 4th. So we've been given 3x to the 7th equals 81x to the 4th. Well, make your right-hand side equal to 0, so subtract 81x to the 4th from both sides. You'll end up getting 3x to the 7th minus 81x to the 4th is equal to 0. What can we factor out between both terms? There's a common 3x to the 4th, right? So we can factor out 3x to the 4th. You'll get that times the quantity of x to the 3rd minus 27 equal to 0. Well, you can divide both sides by 3, which will just leave you with x to the 4th times the quantity of x to the 3rd minus 27 equal to 0. Now that x to the 3rd minus 27 is a difference of cubes, so this will factor into x to the 4th times the quantity of x minus 3 times the quantity of x squared plus 3x plus 9. Well, that quadratic factor is not going to produce any real solutions, so we only focus on the other factors. X to the 4th equals 0 would just give you x equals 0. And that would actually count for 4 of your zeros, since that factor that produces 0 is to the 4th power. And then you have x minus 3 equal to 0, which would just give you x equals 3. So x equals 0, multiplicity of 4, it occurs 4 times, and then 3. So technically you have 5 real solutions, and then you'd have 2 imaginaries. So 0 and 3 are the only listed real solutions to this. All right, last one. 2x to the 5th minus 12x to the 3rd is equal to negative 16x. Alright, so 2x to the 5th minus 12x to the 3rd equals negative 16x. Well, first make the right-hand side equal to 0, so add 16x to both sides. You'll get 2x to the 5th minus 12x to the 3rd plus 16x would equal 0. Now, what do you have in common with all three of these terms? There's a common 2x, right? So factor that out. You would get 2x times the quantity of x to the 4th minus 6x squared plus 8 would be equal to 0. We can divide both sides by 2. That would just give you x times x to the 4th minus 6x squared plus 8 equals 0. Well, that factor to the 4th power, definitely you could treat it like quadratic. That'll factor into x times the quantity of x squared minus 2 times the quantity of x squared minus 4 would be equal to 0. Well, good news is here, everything's going to be a real solution in this case because we have two difference of squares. So of course you got x equals 0. That x squared minus 2 equals 0 will give you x squared equals 2. Well, x would give you plus and minus the square root of 2. And then you have x squared minus 4 equals 0, so x squared would equal 4. X would equal both plus and minus 2. So you have 5 real solutions. X equals plus and minus 2, plus and minus the square root of 2, and then 0. Those are your 5 real solutions to this. X equals plus and minus 2, plus and minus square root of 2, and then 0. So that's it for solving polynomial equations by factoring. The next lesson we're going to get into some polynomial long division. So I hope everyone has a great night. Take care.